We still have a couple minutes though, so we won't get started. How's everyone doing?
Doing great.
Doing
We
great.
have two weeks completed in my case. Yeah.
Yeah, 2 weeks down. Yes.
2 weeks, two labs completed. Students are excited about watching the sky and
Excellent.
using this tool.
Okay.
Yeah.
So,
Yeah.
so you've begun
Sky wheel,
visual observing labs.
visual observing. Yeah.
Mm-hmm.
Moment. Also today will be to see the motion of Earth rotation and using the telescope. Hopefully,
Okay.
today evening will be better sky. Weather will be better. Yeah. So we are doing good. Students are very excited, very excited, very like this course.
Oh, good. Good. You want them to be excited. So perfect.
Yeah, me too. Yeah.
Yeah.
Me too, first of all.
Oh yeah, it makes teaching so much better when the students actually want to be there and are interested in the material.
I wish I could say the same. We had lab on. No, my students are excited, but we had lab on the 3rd, so Sunday, in the middle of a holiday weekend.
Ah.
So I'm surprised they didn't come in with pitchforks and torches.
Yes.
But
that is challenging. How did that come to be?
Our enrollment is so high. I mean, we have almost 250 intro astronomy students.
So you had to open a weekend session and run it on a holiday weekend.
Yeah.
Yeah. Well, it's a good problem to have.
Yeah, exactly. We go shake our fist at the state and say, give us more money.
Yeah. Or give us more days of the week. I don't know. I don't know how you deal with that kind of problem. All right. Well, let's see. Let me check my notes here. I am recording. Let me switch to sharing.
Hey, Dan.
Yeah.
Can I ask you a question before we get started?
Absolutely.
I'm sorry to interrupt the flow.
Oh, no.
So I was looking over my Skynet accounts that got made by you after my students got their WebAssign accounts. And I just wanted to ask you about when I go in. So it looks to me like maybe they didn't, their way of enrolling themselves in the Skynet thing wasn't correct. Can I show you what the class list looks like? And can you just tell me if it looks okay?
Yeah, I'll stop sharing.
Am I allowed to share?
1 second. Yes, you're allowed to share.
Okay, let me see if I can show you what it looks like. Okay, so here's my class list now, which happily is most of the class. Now, some people, though, I can't identify from this list. That's really the question I have. So some people can put their names. Other times it just says self-registration key and this long string.
Okay, so I can answer all these things.
Okay.
The way it works when we send out the invites is it creates a generic account, and its name is temporarily given by the self-registration key. And once they actually open up their email and follow the directions, it will be replaced with whatever username they select in their own name. Now, if you want to know who's associated with each key, go up and to the right in the upper right corner of the page, create user accounts. Down
I see it.
Yep. Okay, click on that and slide on down to the bottom. And so here you can see the email addresses that each of those registration keys were sent to. Yeah.
Great. Okay.
Now, it might have gone to their spam folder, so they have to check for that. But if they can't find it, all that you have to do is give them their key. And so, say, what's your email? You find on this list, copy the key, which is the second column, give it to them, and also slide up a little bit, and you'll see the web address they have to go to. A little bit higher, right there, where it says skynet.unc.edu/user/register. So
Okay.
the automated email they got sends them there, and it gives them their personalized key, and then they use that key to set up their account.
Okay. And I'm sorry if I'm being thick, but if
No, it's okay. Go for it.
if they get into the class too late for you to have done all this for me, then
Slide on up.
okay.
Yep. So you can create the accounts here as well. Well, you can do it two ways. The fully manual way is right there. You say, okay, what username do you want? And give them a password and type in the confirmation, and they can change their password later, and they put their name there, and you can enter all that stuff. Or just slide down to how I did it. Just put their email address in that box a little bit higher. Yeah, that box there, one email per line. Now, the thing you got to remember to do, it's two things. See the little checkbox beneath it, send invitation email to each new user.
Yes.
So otherwise you're going to have to copy the access key and send it to them. And also down where it says time account, initial credit deposit, I changed that to 1,800.
1,800.
Okay. This is kind of why I offer to create the accounts for everyone. Just so you don't miss those steps, because there's nothing worse than creating the accounts for everyone, but forgetting to click that box to send out the emails, because then you got to tell each individual one their key. And also by putting in 1,800 there, it preloads their account and you don't have to transfer the credits. Now, when I created your accounts, I probably sent you kind of a form email with kind of like boilerplate text. And at the bottom of that email is a link that gives you a little tutorial on this page, essentially, and how to add students manually.
Okay, thank you.
Sure. No, I'm glad you asked. This is good for everyone.
Yeah, Dan, I've got another one, but you can probably take it offline.
No, go for it. It's okay.
Well, I'm not seeing any students, and I'm wondering if it's because my Skynet account previously was under my personal email address.
Oh,
WebAssign is under my school address.
Okay. Yeah, let's do that one offline. Send me an email.
Yeah,
so you
like I said, it'll do that offline. I think that's because it's probably a pretty unique situation.
Yeah. I have to kind of, unfortunately, the system for setting up the accounts, I have to go looking for you and make you a group leader. And my only way to search is on your username in the current Skynet. Skynet 2 will hopefully give me more options. So I have to guess at your username. I probably found one that looked right, but maybe that was your personal one and not your, I don't know. So,
we can take. I'll contact you and we'll take it offline. There's another question I have on the WebAssign, but
But send me your Skynet username when you email me.
Yeah, sure.
Okay. All right. I'll start sharing again. I think we'll actually catch up this time. We'll see. I always think that. Okay, let me check my notes here. Just generic announcements. The video from last week is posted at the usual place. And I think you all have this link by now, so I won't put it in the chat. What else? Most groups, all the groups, for everyone who's teaching this semester, all their WebAssign sections are set up. And I've set up most of the Skynet accounts now. If I haven't set them up for you yet, whenever most of your students are in WebAssign, let me know. Or you can just send me a list of emails, your class roster with the emails, and I can set up the accounts based on that, along the lines of what we just talked about. Other announcements, surveys, keep them up. Particularly if you're teaching this semester, make sure you do those pre-surveys and get as many as you possibly can. Feel free to offer extra credit. And again, if you're not teaching, you're just learning, if you're teaching it this semester but not using Skynet, consider doing the surveys, the pre and post surveys as well. We don't have your institution there, but they can go to other and type it in, and that provides us valuable baseline data. Okay, so those are the generic announcements. Let's see. So we're still in lab 1, though we'll finish it today. Last time, and lab 1 is 2 weeks. Week 1 is placing their observations through Skynet. And so, if you're trying this at home, hopefully observations came back. We can check. Let's see. Skynet here. Let's see. I placed a few of them during our meeting last time. 2 of the moon, 1 of Jupiter, 1 of Saturn, and all have been completed. So proof that it does come back, and we're still under the terrible scenario where we don't have our Sir Tololo telescopes. So these must have been completed with other telescopes. It looks like Prompt Meckering in Australia. Let's just take a quick look and see what these look like. This one is Meckering, that's Jupiter. That's pretty poor as far as images go, even from Meckering. If I were a student, I'd probably reobserve that one. Let's see what else we have. Let's see how the Saturn one turned out. Again, we get the best images at Tololo. It's pretty fuzzy, but we're making do with what we have at the moment. And then we had a couple lunar images. Those should look pretty good, even if the atmosphere wasn't very cooperative. There's one, the second one in yesterday or last week.
What was that? The previous image? What was that about?
That was the moon.
Okay.
Yep, and here's another one of the moon.
Okay.
And so this is stuff we talked about last time, how to put observations into Skynet, how the students should check what comes back frequently. They shouldn't just put it in and then wait until the day before they need to use them. They should check if anything looks poor, and the lab gives examples of different scenarios where the observations may look poor, to go ahead and resubmit them. All these solar system targets are very inexpensive. Most of them are less than a second. There are also a few deep sky objects that we image. Speaking of which, so let me pull the lab up here. And Anna, I got you set up here in my section so you can see the labs in WebAssign. I'll bring up lab 1 again. And just a final thing before we move on to week 2. So down here with the deep, oops, something happened. I guess I had it up and it just reloaded. They're observing planets and deeper images to bring out more moons and dwarf planets and a few deep sky objects. As we talked about last time, we have 3 lists: nebulae, star clusters, and galaxies. So these lists are 10 years old, and it was just the best guess that I could make 10 years ago. And I didn't really, I'm not one of those astronomers who knows the night sky very well and very deeply. So I know more about it now since we've been building the astrophotography class, but my grad student's really great at this stuff. And so I sent her, and I'm in the stages of updating some of these OPIS labs. I said, give me new lists. And she produced them. I'll put the link in the chat here. And so you're welcome, these students are welcome to use the recommended lists in WebAssign. By next semester, these will be updated for these here. Put that in the chat. So just lists with kind of cooler targets, better targets. So here, what will be the new list of nebulae, the new list of star clusters. These are all globulars for OPIS here. New list of galaxies, and updated exposures for the luminance filter. Now notice we also have exposures for BV and R. And we talked about last time as a fun extra. It's down here beyond the labs. If they want to make a color image, and students just love making color images. And so we've kind of stuck this in as an extra. They don't have to do it now, but it's there. For us, we're going to find 1 week where there's not much going on. For us, when we do lab 2, we do the globe labs, which the globe version takes 2 weeks, but the second week's kind of light. And so during that second week, we're going to do a color image. And there's a video tutorial here, as I mentioned last time, on how to do a simple red, green, blue. It can get a lot more complicated. And in the astrophotography course, we do some of that more complicated stuff. But I'm going to update these instructions such that if they want, after they've taken their black and white deep sky object, we'll say, okay, pick one that you liked. You know, of the 3 that you did a nebula, a star cluster, and a galaxy. Whichever one was the coolest to you, or go on back and collect a B, V, and R, blue, green, and red, and we can do that. But that's described as optional in the lab. Whether you do it more formally is up to you. But anyway, I just want to go ahead.
Oh, I was going to ask, like, where can we find this document?
I just put in the chat.
Oh, okay. Thank you.
Yeah, so grab it there. And by next semester, it will be integrated into labs proper. We just made it this week. And often I like to, whatever we're working on, even if it's with the astrophotography course or an update to OPIS, I often like giving you those updates during our meeting. Okay. Hide the chat. Okay, week 2. So week 1 was all about observing with Skynet and getting their observations in. In fact, there are no points associated with anything in week 1. Background sections on the basics of what Skynet is, what prompt is, how telescopes work, very superficially, getting their observations in. Now that we're in week 2, hopefully they have most of their observations back. It'll be easier once we get Tololo back online. It's online, it's just the internet's offline on purpose because of the cyber attack. It must have been serious because it's now a month and a half and the whole observatory is still closed. But anyway, once they get their images back, then they're going to start to do stuff with them. It's not enough to just take images. Taking images is fun, but we're going to capitalize on that fun and use it as a hook to start building up a toolkit, a skill set. Lab 1 is not very deep in terms of scientific exploration. We're just saying, okay, here's this new technology, this new toy, let's have some fun with it, and at the same time trick them into learning basic skills that they'll need for the other labs. So things like they're going to learn how to, I'll show you in the tutorial videos. So videos, that's next on my list here. Remember at the top, we had some overview videos. They probably watched most of these in week 1. Here's the overview for week 2. And then embedded in the sections down here are links to how-to videos. And they're also, as I said last time, they're all gathered together on the YouTube site, youtube.com/introastro. So here is lab 1, week 2. We can view the full playlist. Here's the overview video, and here are the how-to videos. So the things they're going to learn, how to load images into Afterglow and view them and adjust the brightness and contrast and save images, some really basic stuff. How to view information about your image, what telescope took it and when. How to measure angles in your image. Here we're going to measure angular diameters of planets. Then other labs will measure distances between like planets and moons or sizes of galaxies, that kind of thing. How to simulate what they just observed in Stellarium. That will help them with moon identification, checking their angular diameters. How to identify moons in their image, comparing it to Stellarium, how to mark those and label those in their image. And also how to identify dwarf planets, which usually just look like another star. How do they know that that one is the dwarf planet? So we teach them how to compare it to an archival image from decades ago when the dwarf planet wasn't there in the sky. So those are the skills they're going to learn. And then there's this final video on how to make a color image. That's the bonus that I was talking about. Okay. Let's see if there's anything else here in my list. Oh, and then the other thing is, before I jump into these tasks. Again, when you're doing the lab, you're often going to have like a pre-lab presentation, maybe 15 to 25 minutes, depending upon how much depth you're going to go into, how much there is to cover. But before moving into the lab, you probably want to say, okay, everyone stop, open up your laptops. We're going to put in the next observation we need. And so this is a good time to put in your observations for lab 3. Lab 2 is one of our manual labs, one of the non-Skynet labs. Lab 3, they'll be watching a moon go around one of the 4 gas giants, whichever is observable. This time of year, they can choose between the observable ones, and they collect data once a day. You could do it twice a day if you want, like Chile, Australia, but at least once a day. And we try to get at least 5, 6, 7 of these. We tell them to try to collect 2 weeks of data. The more data they have, the better the analysis will be. They'll see the pattern. They'll be able to determine the orbit. I'm not going to go through that right now. We'll go through that when we do lab 3. I'm just pointing out that you may want to, or you definitely want to put those observations in at this point. And if you find yourself in that position before we cover it in our training sessions, you can just go here to lab 3, how to monitor an object with Skynet. That will tell you how to put in a repeating observation. Okay. All right. Let's go to the lab. Okay, first up, and feel free to interrupt with questions at any point. First lab, or the first item in lab 1, week 2, planet and dwarf planet images. So immediately starts with the link to Afterglow. This is our web-based image analysis software that you'll learn a lot about. And then tutorial on how to, that first tutorial that I mentioned, how to view your images, adjust the brightness and contrast. We'll come back to these instructions in a second, but let's just go to Afterglow. And there are actually 2 versions. There's, sorry, I have a summer cold. I'm hopped up on cold medicine too, so if it makes sense, just let me know. Afterglow.skynet.unc.edu is the main one. Though if for whatever reason it's not working, there's a second installation. I'm putting it in the chat right now, afterglow-dev.skynet.unc.edu. It doesn't have as many cores behind it, but it's still pretty powerful. Often, well, the point of the dev version is as we're continuing to add features to Afterglow, we add it to the dev version. And as that stabilizes, we move it over to the production version, which is afterglow.skynet.unc.edu, the one linked in the lab, the one we're looking at right now. So just, so you know, if Afterglow ever jams up for whatever reason, just switch to the other one. Let's see here. Hide the chat. Okay, some basics. Initially, they'll come here and it will look blank if they don't have anything loaded. I have a handful of images preloaded, but let me show you how to load images first. So you go over to Open Files, and let me go back here. When they open it, it will, I was already deep in a directory structure, but it will look like this. And you'll see 3 directories typically, sample directory, Skynet, and workspace. If you have access to Las Cumbres telescopes, we're working to integrate their database into Afterglow as well. They want to use Afterglow. The sample directory, they usually won't need to go here, though under Astro 101 Lab, Lab 3, Lab 4, Lab 5, we do have some sample data in case you have problems collecting. These are large observations where you put one in for the whole class, parallax or an Lyrae. If it just doesn't work out, they're back. Workspace, if they're working on something, everyone has a personal workspace. They can save it there and reopen it. But most users will want to go into Skynet. And you come here and you'll see user group collaboration. Their observations will be under user. If they go to group, they'll see all the groups that they're in, which is probably just the one group, their class. They can go into it, and then All the students will be listed and they can go and grab their data. In Skynet 2, we're going to have more restrictions. The instructor will be able to control whether they can go into the group directory or not. But in these later labs where we collect one data set for the class, they'll probably want to navigate. The way they'll get to it is they'll go into the group, and whichever user, it might be you, the instructor, who collected it, and then go in there and get the data. But normally they're just going to their user observations. And it loads pretty quickly, though sometimes for me and Josh Hayslip, my lead programmer, it could take 30 seconds to load because we have like a lot of observations. Anyway, when you first come here, it's normally sorted by name alphabetically, which is not the most convenient. So you often want to click on last modified and maybe click on it again to put the most recent stuff at the top. And so you see those, the last images I took, the 4 that we just looked at, the moon, Saturn, the moon, and Jupiter, and then I have previous ones, and it goes forever and ever. Let's load something in. Now, how about something different? There's something interesting here. Yeah, let's try Messier 16, Eagle Nebula. So when you go into your observation, you should see reduced images, raw images, and master calibration images. The images that come straight off the telescope are raw, and they have all the defects of the camera in there, out of focus dust donuts, and they don't want to use those. Skynet automatically collects biases, darks, and flats and makes master biases, darks, and flats. And these are the things you use to correct your images to make them look good. And we don't teach this in OPIS. We've decided this is a more advanced thing, that something maybe an astronomy major will learn, and not necessarily a survey level student. So they want to go to reduced, where we've already taken the masters and applied them to the raws. And so here their images already reduced. I'll just open this first one. It's a luminance image, 20 second. So that's not very long. I would probably go, well, yeah, I've seen better. But anyway, yeah, there it is. You can kind of see there's the eagle there. I may have imaged a little bit longer, or maybe it was just poor conditions. I don't know. I just selected that one kind of randomly. But you see it loads in, and I can't remember. Did it load as tiles, like 1, 2, 3, 4? Or did it just all pop in? Let me load another. This may have been the one when I was practicing, this may have been the one I loaded. I want you to see how it loads. I don't know, let's load an H alpha image that I happen to have here of the Eagle Nebula. So you see it's loading in tiles. Yep, now that looks better. This particular camera has a defective column. So you may see that right there. There are ways to get rid of it, but we don't worry about that in the OPIS course. Okay. What else do we have here? So once it loads in, this was a 2K by 2K. So it loaded in 4 tiles. It loads a 1K by 1K tile at a time. It's a Google Maps kind of interface. You can drag it around. You can zoom into any particular position. It's pretty intuitive. Oh, another thing I should mention, control plus, control minus. Let me go to 100%. So when you first open this and your students first open this, this is what the screen looks like at 100%. And it kind of doesn't give you a lot of space here where the image is. I normally like to control minus a couple times, give myself a larger viewer port to work with. Of course, that's going to make all the text and everything on the side smaller. These sides, you can also hide them and create more workspace. Now we have some controls down here. There's zoom in, zoom out. Though I like using my mouse, and I actually use a USB mouse. You can use the mouse pad for this. It's just a little bit harder to control. You may want to consider getting a box of USB mice just to go in the lab for students who want that finer, more precise control. Scroll wheel USB mice would be, oops, that's my mic, would be my recommendation. But it's not necessary. This right here zooms to fit your viewer port, and this resets it such that it's the natural pixel scale of the image. You also have two buttons here for downloading and printing out images, and come back to that. Over here, you also have, well, for each individual one, you have a save. You can save the file, you can close it out. Like, let's see, I don't want that luminance one there anymore. Close it out. You can select all of them or certain subsets, and then up here you can save, you can close them, you can refresh them. Here's some advanced things if you want to group them to make color images. So just basic controls. Also, if you click on it, it loads it in. And you can see it's in italics here. That means it hasn't been pinned. If I double click it, that pins it and went from italics to regular text. Now, if I click on something else, it opens it as a new tab. And as I click on different things, it keeps replacing that. But if I double click it, that locks it. And now clicking on things opens a new tab. So we have a tab structure here. And you can actually split the viewer. If you right click, like I can split down and have multiple viewer ports, or maybe this one here, I can split left. And so you can break this up into multiple viewer ports and just hit the X to get out of it. Okay. All that straightforward. It's real basic stuff. Okay, brightness contrast. Let's go to an image of Jupiter. And if I go fast here, it's okay. All this stuff is in the how-to videos in much greater detail. In the how-to videos, I speak at a very slow pace. It's for the accessibility. We may add sign language at some point. So, you know, it's there, it's slower, it's in more detail if you need to watch it again. Or if it's too slow in YouTube, you can play things at like 1.25, 1.5 speed. Anyway, okay, let's look at brightness and contrast settings here. So this is Jupiter, and here we can see the 4 moons, but Jupiter looks pretty poor. And it's just because of how the brightness and contrast are scaled. Astronomical images are 16-bit. There's more information here than you can see at once. So you have to pick, do I want to see the faint part of the image and saturate the bright part? Do I want to put all my dynamic intensity range on the bright part and lose the faint part? And this is kind of the default setting. Over here, this first tab is display settings. We have a histogram here. This is, and it's logarithmic on this axis, linear on this axis. So it's saying there's a whole bunch of pixels that have a small count, that's the background, and a small number of pixels that have larger counts. Those are the objects. We have some presets. This is the default. Here's faint, which is going the wrong way for planets. Here's bright. And the bright target default's really good for planets. And here's a better image of Jupiter. The one that I showed you before was taken under blurry conditions in Australia. This is Tololo. This is typical of Tololo. So hopefully that comes back online soon. Now these presets are really just changing the background and saturation levels. Actually just the saturation level. If I go to default, it's blown out here. We're looking at sky glow. This is bright light bouncing around our atmosphere. And so we lose all structure here. But you can also fine tune it, 99.9. Maybe 0.8, 0.7. I'm slowly saturating it. I can also use the arrow keys, bringing out the moons, or you can go the other direction. Okay. And so for bright planets, we tell the students to use the bright target preset. You can tweak it a little bit if you want, that's fine. What else do we have here? The background level's good with nebulae. Like here's tarantula. I've got that bag column, but that's the default. Here's the faint. It can bring out the background a lot more, though the faint stuff a lot more. But often you may want to raise the background to darken the image. What these numbers are 10, 99, it means the faintest 10% of the pixels are being colored pure black, and here the brightest 1% pure white. And so by increasing this, I'm increasing the number of pixels that are pure black. And so you can adjust things that way. It normally starts on linear. I had that on something else. So here's linear default, linear faint. And that's another setting here, the stretch mode. And particularly when they're working with their deep sky objects, they may not want the linear stretch mode. You can see here the default setting or the faint setting, it really blows out the center. They may want to try some of the others like hyperbolic arc sine or square root. It brings, or logarithmic really brings out the faint end, but in this case, I would increase the background. Again, they can play until they're happy. We've added one called midtone. You know, often you have to hit the default after you change the stretch mode. Midtone's nice because it doesn't blow out the bright end or the faint end. You can see both the faint structure and the bright structure. Anyway, some basic tools there. There's an inversion tool that does not work with midtone, but with any of the others. You can invert the image. Sometimes they prefer that. I think that's it. Oh, also you have different color palettes if you want. There's like, I'll turn inversion off. There's a rainbow palette. It's like a heat map. And these are not real true colors. It just gives your students a little bit of creative freedom if they want. Okay, so those are the display settings. Let's go back to the lab. Again, if you have questions at any point, just shout them out. So here we tell them to grab their planets and the dwarf planet series, zoom all the way into the object until it fills the viewer. We don't want them submitting an image. Let's grab Saturn here, like this, and submitting that. Instead, we want them to submit something like this, and this camera button spits it out as a JPEG, and that's what they would upload into WebAssign. Also, when it spits it out using the camera button, or this one right here spits out every pixel. It's good if you're doing astrophotography. Let's see here, where'd it go? Downloads. And we'll spit out every pixel native resolution there. Okay. But here in OPIS, they'll zoom in and print out just a little stamp around the area of interest. And there's this thing called EXIF. In JPEG images, you can embed some additional information. And they don't know this, but we're embedding the name of whoever is logged into this Afterglow account, and also the name of the user that took the data and when it was taken. And you can load, I have mine right here, EXIF Viewer Pro, and there's more information about this in the grading guide. Let me just put up something here, the screen right here. So once this isn't WebAssign, but once they're in WebAssign, you're grading, what you can do is you can right-click, show EXIF data, and it shows you whatever information is attached to it. This one doesn't have it, but you get the idea. It will have the name of the Afterglow user, the Skynet observer, and the observation date, and it's a one-click cheating check, right? I can go to any image here. That's just a regular picture, but you get the idea. One-click cheating check. Make sure that they're turning in their own work and not somebody else's. Okay, back to the lab. So zoom all the way in, adjust the brightness and contrast, bring in as much detail as you can, save it as a JPEG, upload it into WebAssign. We do a little bit of expectation setting here. We're saying, okay, here's Mars at closest approach. This is as good as Mars gets. You can barely see the ice cap and maybe some shading that does match. But this image right here on the right was taken by Hubble Space Telescope. And often they'll think that this is what they're going to be getting back. And so it's important to set expectations. that no, we're not in space, we're not in orbit around these planets. You're using small telescopes from under the atmosphere from far away. So the coolness is just being able to detect these things and maybe make out some structure. We're in answer key mode here, so they don't see the answer keys. But this just gives you an idea of what these worlds may look like for your students. There's Venus, if they can get it. It's usually too close to the sun. Mars at closest approach. Sirius, they won't see any structure. Jupiter, they will see structure. Saturn, some. Uranus and Neptune, they won't. It'll be a fuzzy blob, but it will be a bigger fuzzy blob than the surrounding stars and moons. This is a new feature to the lab. There's a place where they type in their observation number from the Skynet page. And this makes it easy for you to go and look at those observations. If you bring up any observation in Skynet and just swap out this number with whatever they entered, it'll take you directly to their data. So if there are any issues, you can go to the raw data there. And we also have them put one fact about each of these worlds. Again, this is not a scientifically deep lab. This is, let's have fun and learn the tools at the same time. Okay, that's brightness and contrast control. Let's move on to measuring angular sizes and information. So here's a tutorial on how to view basic information about your image, like what telescope took it and when it was taken. And here's a tutorial on how to measure angular diameters. And so we have them go through all the planets. Again, this is answer key mode, so it looks like a mess. They don't see the green boxes or the X's. For them, it'd be very clean as a table. But they'll enter, were you able to observe it? May not be currently observable. The telescope that took it, when it was taken. This is so you can check it in Stellarium, and also so they can as well. And their measured diameter. Let's start with the diameter, and then I'll show you the info, how to get the info. So here in Afterglow, if I want to measure the diameter of, let's go to Jupiter actually first. That's the fourth tab down, the plotter. Once you're in here, you can, for this, you don't want to do it like this, right? You want to really zoom in. The students want to zoom in, fill their view report. And you click on one side, you click on the other. And so Jupiter is, in this image, is 46.366 arc seconds across. Of course, there's some arbitrariness of where they put the edge. That's atmospheric blurring, pixelation, yeah. I'm inventing words. But that's stuff that can go into their sources of error. And if you're kind of demoing this stuff before the class, here's a fun thing. We don't do it in the lab. Jupiter's 46 across, but if I go from pole to pole, I got 44. I got a smaller number. In fact, I kind of went too far out here. Jupiter is a oblate spheroid. It's a rotating ball of gas. It would be wider across the middle than from pole to pole. And it's something by about 6%. And it's something you can measure in your image. With Saturn, we have them measure across the rings just because it's a little bit easier. And with things that have a phase to them, like Venus will often have a phase, we're clear they want to image from pole to pole, not the short distance, but the long distance. So they put those there in arc seconds. To get the info about the image, you go to this eye, it's the second tab down. There's the telescope that took it. You have things like filter, exposure length, and then the center time is the time that this image, year, month, day, hour, minute, second, it says GMT 0, that's essentially universal time, Greenwich Mean Time. And they'll enter that stuff in their table because they'll need it in just a second. They're going to check it in Stellarium, and you may want it to check as well. There's a box here where they sign their name. They view this as an honor code check. But really, there's some manual grading with this table. It will automatically check whether these diameters are within plausible ranges. But you'll probably want to go through and count up when we go to the grading guide, there are instructions on how to do this. And they may put numbers in even if it wasn't observable, so you want to make sure they don't get points for that. And basically, you're going to add up the check marks and And this is basically a place that you can put a score. So for them, it's a honor code check, but for you, it's a place that you can add points, deduct points. Again, they don't see the answer key until afterwards. Now, here we're going to check it in Stellarium. So let me open Stellarium here. I'll show you how to do that. We'll do the Saturn image, I think. So when you open Stellarium, it opens full screen, and you can't figure out how to minimize it. It can be really frustrating. Function F11 minimizes it, or shrinks it, so it's not full screen. Okay, the first thing you want to do, and this is described in the videos in the lab, is they want to come over, and you can lock these tabs into place by clicking here and here. And you click on Location window, and they're going to put it in universal time. It's probably in the time zone of their computer. They come down here to UTC and select UTC or UTC plus 0. You're in universal time. They want to make sure daylight savings time is off. And then you do that, and their images will match what's in Stellarium and vice versa. We don't really have to set a location. We can come down here and turn off the ground and turn off the atmosphere. Just kind of checking. And let's go and find Saturn. You can zoom in here. And if you want to orient, if you go too fast, it doesn't get the picture of the planet in there. There we go. Okay. And if you want to orient it the same as these telescopes, there's a little mount icon down here. Okay, so now it's oriented the same as the images. All that's left is setting the time. Let me shrink this a little bit. And we got the time here. And so we bring up the time box. And this particular image was taken in 2019, October, let's type it 18th at 23:58. And the seconds don't matter. I've lost Saturn, so let me come back here again. Okay. Okay, and let's see if this matches our image. Well, I'm jumping ahead to moon identification. I guess we'll just see. I'll come and put it on like default here. Tamp down that Saturn glow. And if you look at the distribution of moons, it matches perfectly at, what's in Stellarium. But we'll come back to that in a second. The key thing they're getting out right now is the angular diameter. Trying to unlock that tab. Anyway, it's down here. Angular diameter has it both without and with the rings. For Saturn, we use the rings, so 38.04. And what did we measure? .38. So similar. Okay. So back to the lab here. They're going to put Stellarium's angular diameter in here, and they're going to compute percent errors. And I have an example calculation. We're adding these to the labs. Labs 1 and 2 have the example calculations now. The later ones don't yet. But it links to a PDF that has an example of every type of calculation in the lab. I think this will be a big improvement. We've changed how we describe percent error. It used to be like measured value minus true value divided by true value. Absolute value times 100%. A lot of the educators didn't like the term true value for philosophical pedagogical reasons. So we're replacing it with professionally best determined value. You'll see that in the first 2 labs, but then it will resort to true value because I haven't updated those yet. And actually, in this lab, they missed one of them. They're going to have to go back in, and so minus true value divided by professionally best determined value. But true value and professionally best determined are the same. That's just a little bug that will be fixed pretty soon. So percent error calculation, they learned about the absolute value sign, absolute value. 113, it's a Star Wars reference. It appears everywhere in Star Wars. So that's a little nerdiness in the lab there. Sign their name. They present their error calculation, and then sources of error. And so this is their first sources of error discussion. And so, we make a note: human error, measurement error, calculation error, not valid. If you have a calculation error, recalculate it. If you have a measurement error, remeasure it. If you have a human error, find another human to help you do better. Of course, students have a terrible time with sources of error. Here we give them a little bit of hint. We tell them to think about atmospheric blurring, and we ask them, why did the smaller objects have bigger percent errors? And think about it. Atmospheric blurring will blur you out like 1 or 2 arc seconds. So if your object is Ceres, which is naturally 0.6 arc seconds, and it's blurred 1 or 2 arc seconds, that'll be a huge percent error. If you have something big like Jupiter that's maybe 40, and 1 or 2 arc seconds of blurring maybe makes it 42, that's going to be a small percent error. So we give them points if they talk about atmospheric blurring, more points if they can describe that effect. There's something here talking about measuring, the edges of objects, which are blurry and pixelated. And so they can't see the key, of course, but as we talked about before, as they go to each future lab, right at the top, it says, stop, go to the previous lab, read the answer key for your sources of error. So they'll never get it right if they don't study how they got it wrong. But anyway, you may want to hold their hands through this first one. Okay, we have about 10 minutes left, but the rest is pretty quick. Moon identification. And we kind of got there. Again, there's a tutorial. And so let's just do the same Saturn image. So here's Saturn at the time the image was taken. Let me get Afterglow back up here. Okay, so coming back to the display settings, I'm going from bright target to default. And in the video, we tell them what to do here. There could be moons lost in the planet glow, right? They can't use the bright target because they can't see the moons. And if they use faint or default, they may be losing some moons. So they adjust it. They try to minimize the glow, seeing if there are any moons under there, but they don't go so far as to lose their moons. They find a happy medium. There were no moons under the planet glow in this one, but sometimes there is. And then they compare it to Stellarium. So that's Titan, Iapetus, Rhea Tethys, Titan, Iapetus. There are 2 here. It's probably just Dione. Oh, it's Dione and a background star. Background stars can sometimes confuse them. Sometimes Stellarium doesn't show enough background stars. So there may be extra points here that they think, oh, is that the moon? There's a way in Stellarium that you can add stars going deeper. If it's an issue, email me and I'll remind myself how to do it. But you can go into settings and add, fainter stars so they do appear in Stellarium, and so they don't confuse stars and moons. When I'm grading, I'm pretty generous. If they confused a star for a moon, it's in the right place. I don't worry about it. Now, what they're going to do once they identify them is they're going to mark. Yeah, please.
I found last time when we did this, the students had a lot of trouble getting the angular size of the Stellarium scale to match their angular size of the image scale here. So one thing that they sort of tripped on sometimes was understanding what angles were being represented in Stellarium versus here. Do you have a tip for that?
Yeah, so I'm trying to unlock this. If I could unlock this, I could read the word better. I don't know what. Oh, there we go. Okay. So now there are all sorts of diameters here. They're looking for apparent diameter. It has it without the rings and with the rings. And so they're definitely going to want to use the rings for Saturn and without for the others. That's the first thing. The second thing is they're going to get different values in their images because of atmospheric blurring. With big things like Jupiter, Saturn, Venus, the atmospheric blurring is a small percentage compared to the large object. But as they're doing smaller objects like Uranus, Neptune, especially Ceres, pretty much everything they're measuring is atmospheric blurring. So they get huge percent errors with the small objects and small percent errors with the big objects. And this is...
Oh, I kind of meant for this moon stuff. They'd sometimes mistake stars that are very far away as the moons of the planet.
Okay. When you said angular diameter, I thought you meant of the planet. You're talking about the image, right? Like they could be here and start saying, okay, this is, or a good example is actually in the lab here. It could be tricky. Like here's Uranus. Uranus is the toughest one. The moons are faint, and of course, the farther the planet is away, the closer the moons are to the planet, angularly. And so often some moons will be lost in the sky globe. This is Oberon, Umbriel, Titania, but Ariel and Miranda are lost in the sky globe. But they could easily say, oh, that's Miranda, that's Ariel, this is Umbriel, and thinking that this is that.
Right.
So we encourage them. I think the way we encourage them, we should probably read the text, is we tell them to, let's see, after zooming in to the planet stellarium, remember to view it equatorially and then zoom out far enough to match as many objects in your image as possible to stellarium simulation. So, as they zoom in, I think it's stellarium here. When they zoom in, we have them zoom out first. And zooming out is probably the way, because then they can identify the outlying ones. If they zoom too far out, then it's clearly not going to match. But they zoom far enough out where they can see words still, and try to match up the outlying ones first. I guess that's my advice. It is a little tricky, particularly with Uranus. And I think last semester it was or one of the recent semesters, Uranus was the only gas giant available. Okay. Again, I think we'll be able to finish in time. Marking and labeling their image. So you come over here to the custom markers. You may want to turn on centroiding clicks. That way they don't have to be too careful. They can click anywhere in there. And they can mark their moons. I forget which one's the moon, which one's the star. This one's the moon, that was the star. And click on it again, and they can add a label. This was Titan. And they can do some fine adjustments. This increases the radius of the circle. This increases the radius of the label. This increases the angle, or changes the angle of the label if it's a crowded field. You wouldn't want your marker to be that big, but you get the idea. They can mark these, they can label these, frame it up. Don't submit that. They want to submit this. And again, they download the snapshot, and then you have that snapshot, and they can upload into the lab. So here are some examples of what that looks like. Now we give them one example to work on, but here's in answer key mode. They submit their image. They also submit the date and time, so you can check it real quick. It's good if you have a double monitor as you're grading. You can just have Stellarium open on your second monitor, and you can very easily hop between planets and dates and times and check their moon IDs. They also provide their Skynet observation number and one fact about each of the moons that they detected. I'll skip over dwarf planet for a second. We'll end with that. But for deep sky object and lunar image, it's basically they're just adjusting the brightness and contrast until they bring out as much detail as they can, and they submit it here. And a fact about each. Now, these are more for fun. But the dwarf planet identification. So that's the last thing I'm going to show you. So let's bring up this image of, I think I have Pluto here. So one of these points of light is Pluto. Which one is it? So what they do is they open up the Digitized Sky Survey. This is the one they took. If they come over to this gear tab, they can import the DSS. And right now it's use intended pointing for image center. If the telescope pointed perfectly, Pluto will be right at the center, but telescopes don't point perfectly. But we can import the DSS such that it's perfectly pointed where we wanted the telescope to be. Now, Pluto won't be in the Digitized Sky Survey. This was probably taken in 1990-ish. But let's split the screen. I'll split this down. So there's the DSS, and here's the Pluto image. And we can click sync orientations. Now this locks them together. This is going to be super helpful. And so I'm going to zoom in on the I'm going to go to the DSS one, zoom to fit. I'm going to zoom in on the very center because Pluto will be near here, near the center of this image, but in the image we took. You could probably already find it. But we ask the students to add reference points, to mark references, like these three are these three. This one is this one. You get the idea. But there should be an extra point in their image that's not in the archive. So that right there is Pluto. Anyway, and so they download it, they download the reference image, and they'll upload those into the lab as well. And I think that's basically it. Having fun, imaging some inexpensive objects. In terms of telescope time, these are real cheap, and so they can do it multiple times if there are problems. They get a taste of a few deep sky objects. They're more expensive in terms of observing time, but they're basically having fun, learning how to use the system and learning some important analysis skills that will serve them well for the rest of the lab. And that's it, I think. Any questions?
I have a couple quick questions, but I don't know if people need to go or you need to go and I should ask later.
Yeah, if anyone needs, we're now at 12. If anyone needs to go, feel free. But otherwise, I'll be here for another 15 minutes till my TAs show up. So go ahead, shoot.
Okay, great. This was awesome, Dan. This is so helpful. Thank you. So my first one is just, I put in a bunch of observations and they came back and my list doesn't look like yours.
I'm sorry. I'm up on the second floor and I guess today is bug cleaning day. This giant brush just struck my window and shocked me. So what the hell? Okay, so, go ahead. You're gonna have to re-ask your question.
Okay, sorry. So in my list of optical observations, the layout is just different. So it says multiple telescopes and I don't have an image until I click on the ID.
Go ahead and share.
Okay. So, you seen that?
Yeah. Okay.
So here's my list.
Yep.
And it seemed like yours actually had the telescope there. And then when I like click on an ID, I find the JPEG over here. So I'm just wondering if I have some setting wrong.
Okay, so multiple means you selected multiple telescopes. If you only selected one, it will list that one on the previous page. If you selected multiple, use the first available, it will say multiple. Okay. When you come here, it shows you which one it did select.
Right.
Actually, if you look at down at the right under observation info, you can see you had 4 telescopes selected as potentials, and it chose prompt use ask.
Right.
Now, I had the thumbnails. And so if you go back to the exposure box, the blue box,
yeah,
and click, go over one more to the right, one to the left, that one, click there and you'll see thumbnails.
Oh, great. Okay.
Yep. And so you can thumbnail view. The thumbnails can be annoying. Like once you get into the astrophotography course, you may take 30 images on a 2K by 2K or 4K by 4K camera, and then they're much slower to load.
Okay. And so then you can just turn them off. Great. Thank
Yep.
you. All right. So my other question, last week we were all evacuated from our building. So I was listening on my phone and I think I missed a couple things.
Okay.
When you put in the observations, there were the defaults for like where the sun is and things like that. What do you recommend for and then the lab tells you the suggested filters. What do you recommend for the moon?
Right. Yep. That's a new addition. And so it's not in the instructions yet. The default should be phase of 100% and moon distance of 30%. And so those are the defaults that we recommend for OPIS. Basically, we'll observe in bright skies and even somewhat close to the moon. Now, when they do their lunar image, an error will pop up saying you can't image the moon more than 30 degrees from the moon. So they'll change it to 0.
Okay.
And that's just one of these things where the interface changed and the instructions haven't yet, but by next semester that should be rectified.
Okay, yeah, that's fine. I just was wondering if there were any other than the defaults that you recommended at this level. Great.
130.
Thanks.
Other questions? Anyone?
Yeah, Dan, I had a question. The selected on the telescopes, this actually got brought up in our weekly instructor meeting. Is there, I think I saw you mention that there was a way that you could just select all the available telescopes.
There's an orange dot. So on the right where it lists it, so on the right here, I can share.
Yeah, thank you. Yeah, if you would. Elise was asking about that. I was like, I'll mention it today.
It's not super apparent. It's not at all apparent. So hopefully in Skynet 2, the new design's a little clearer. Skynet, optical observing, had a new observation. M2, it's a glob. Okay, am I good? Get my standard defaults in there. Using submit filters, and let's say I just want high through, save and continue. Okay, so selecting all. Over here on the right, we have time accounts. And most likely you only have one time account, or your students only have one time account. If you select the orange button there, it will automatically select everything in that time account.
Cool. All right.
Now, if you have multiple time accounts and you just start selecting things, you may end up with a combination of telescopes that's not represented in any particular time account and puts up a warning. It won't process. Basically, the telescopes you select have to be a subset of whatever is in that time account, in that time credit account. But the orange button's the quick way to do it. Again, there are two ways to do this. The lab tells the students to go through and find the prompt telescopes and select them. But if you're running out of time or desperate, or if a lot of the prompt telescopes are down because of cyber attack, you may want to select all. Though we still have a few. We have prompt Meckring and prompt USASC, one up in the north, one in the south. But it really depends on how much time until their lab is due. If they have 2 weeks, maybe they hold out. Or if Tololo comes back online in the next couple of days, they may want to resubmit. And again, resubmit is easy. You have any observation, and it's not what you asked, but just extra info that's helpful. I'm going back to my observation list. Suppose I want to resubmit this image of Jupiter. I can come here and just press resubmit and submit, and it's back in the system again. Oh, that wasn't the point I was trying to make. Resubmit, you come back to telescopes in the breadcrumbs here at the top, select the new, the prompt telescopes that have recently become available, and then submit. Anyway,
Thank you.
as soon as those scopes come back, I'll let everyone know.
While you're on this page, it also seemed to me you have to choose filters before telescopes, because I chose telescopes once first, and then it didn't give me all the filter options, even though those telescopes had
in
those.
the
You need to
lab,
choose-
we recommend choosing filters first, and then it will narrow the list of telescopes down to the, so basically the idea, the philosophy is design the observation you want. So I want this target, I want this filter, and then it will tell you what telescopes can do it.
Great.
Some people go to telescopes first, just because they want to observe with a particular, I got to pick a target. They want to observe with a particular telescope. So we give that option first. They can go here and say, okay, I always use prompt 5. I don't want to mess with the rest. And then it will narrow down the filters to those that are on prompt 5, I think in this, I never observed this way, but yeah, prompt 5 has a lot of filters. But for example, if I come back to telescopes and select prompt 1, and it has basically an open filter. Yeah. But yeah, filters first in OPIS and then the telescope. The only time that that's different, perhaps, is with it doesn't have to be different, but with the lunar observation, they do have to pick one telescope, because each telescope has a different field of view and they're carefully positioning it on the lunar disk. And so it has kind of special instructions where they go through, and then we have them go pick one telescope and go back and frame it up and then go forward again. Now in MWU, we do a full mosaic of the moon, like 5 by 5 times 3 filters, and they do a color image, and Afterglow can stitch it all together, and it's pretty spectacular. But walk first, run later. Anything else?
Dan, I thought of one possible additional idea for the problem my students had last semester with sizing. Would it make sense if before they adjust the images that they take with Skynet to show the moons most effectively, they go to show the planet effectively and then make that planet match the size of Stellarium planet? Then the scale in Stellarium will be matched to the image better, maybe.
That's not a bad idea. Yeah, I'll put some thought into that, and since I'm updating instructions, I'll see if that's something I can work in. Yeah, thinking about it's probably not going to work great with Uranus and Neptune, because it'll work okay, but the atmospheric blurring is a good fraction, maybe doubling the size of the disk. But certainly with Saturn and Jupiter, that could set the scale.
Yeah, but they didn't have much trouble with those two. They really had trouble with, like, they were choosing background stars that were very far from the planet, thinking they were the moons of the planet.
Maybe the hint should be that as you get farther away, Uranus and Neptune, the moons will be closer in the planet. Yeah. And with Neptune, I forgot to mention, when they get to Neptune, I have it here, just, am I sharing? Yeah. Here's Neptune. When they get to Neptune, they don't even have to use Stellarium. So let me get rid of this. There's a Neptune image, and you can always identify it's the one with the tiny moon right next to it. But some people will say, okay, there's Neptune and there's Triton, because it's the next brightest thing in the image.
Right.
But it's always going to be very close, hugging the planet. And I think I have better instructions in there for Neptune now, but maybe I need to generalize that for Uranus, saying the moons are going to be close to the planet.
Right. Thank you.
That's a great idea.
Thanks, Dan. Really appreciate it.
My pleasure.
Yeah, thank you, Dan.
Thank you, Dan.
Thank you.
See y'all.